Wow.
All right, finish up here, section 4.6. 4.6 was about looking at, or actually writing, I should say, writing slope-intercept formed equations. So what we did so far is we've been able to look at graphs, determine what the slope of the line is, determine what the y-intercept of the line is, and then write the equation using the m and the b values. But it's not only looking at graphs and doing that, it's also about looking at points and doing that. Okay, like we did here in this example. In this example, we were able to find the slope, just like on the quiz we went over, by doing y2 minus y1 and x2 minus x1 to get the slope, the m value. And then they actually were nice enough to give us the y-intercept value. The y-intercept will always have the x value being 0. So if they give you a point where x is 0, that is the y-intercept. For example, C, did they give us a point with x being 0? So this is the y-intercept. I just need to find the slope now. So I actually like the tables better than I like the 2 points. Here's why I like the tables. To find my rise, I have to find the change in y. So to go from -10 to -6, are they adding or subtracting? Adding what? Adding 4? Okay, so my rise is going to be 4. My run is the change in x. So to go from -2 to -1, are they adding or subtracting? Adding 1. So my run is 1. What's 4 over 1 reduced to? 4. I'm doing the same thing that I did up above, but for whatever reason, doing it on a table, it's easier to do without having to write the subtraction out like you did right there and right there. Okay. So my slope is 4. What's my y-intercept? I circled it for you. What is it, Dawson? Nope, that's the x value. What's the y value? Shane? -2. So the x being 0 tells you this is the x-intercept or the y-intercept, and you have to look at the y value. It's -2 there. And so my equation, what's my equation going to be, Oliver?
Y equals 4x minus 2.
That's right. Example D, did they give you the y-intercept? Is the x value 0 anywhere on this table? Yeah, okay. So this is the y-intercept then. What is the y-intercept? 0, because if the x is 0, whatever the y is at that point, which is also 0, is your y-intercept. So this actually goes to the origin. So look at your points here. What's happening to the 6 to go to 4? Subtract 2. Okay, so the rise is -2. The run, what's going on here from -3 to -2? Adding 1, so it's +1. So -2 over 1. What's -2 over 1 reduced to? Go ahead, Sky. Just -2. So our slope is -2. And Jacoby, what's our equation going to be then? That's it. That's right. Yep, you're right. You wouldn't write the +0 unless you want me to make fun of you, remember? Jacoby didn't want me to, so. All right. Now, if, this is important, if the y-intercept is not given to you, then you're going to have to do some work to find it. You're going to have to plug in x, y, and m to the slope-intercept equation, and I'm going to show you what that means here. So first of all, do you understand what I mean by the x is not given to you? The y-intercept's not given to you. There isn't an x value up here of 0, is there? So they didn't list the y-intercept on the table here, the chart. So we can still find the slope. Is the y increasing or decreasing? Increasing by 3. So that's our rise. Our run, is it increasing or decreasing? Increasing by 2. So that's our run. So the slope is going to be 3/2. But we don't know what the B value is. So here's what we do. We write the slope-intercept equation without anything in it, mx plus b. We plug in 3/2 for m, pretty obvious. And then you get to pick any point on the line and actually plug it in for x and y. Now, we know of 4 points that we are for sure that are on this line. What's the easiest of those 4 to plug in? Lizzie? 1/2. Okay, so plug in 1 for x and plug in 2 for y. Now we can literally solve for the b. That'll be what our y-intercept is. What's 3/2 times 1? 3/2. Can I call it 1.5? You guys okay with this? I'm not finding the slope, so I don't technically have to write it in fraction form. Or, I mean, you could. Subtract 1.5 from 2, what do you get? 0.5 or half if you want to write it in fraction form. So our slope was 3/2. We knew that right away from just looking at the line or looking at the chart here for how long it'll take them to realize.
I think they did it on purpose.
Yeah. No, that's funny. That's funny.
Oh, I keep trying to see who it was.
How could you?
Darn, I don't know. I thought I might be able to see them click the correct one they want to connect to. I bet it's Mr. Grinstead who clicks on mine purposefully. He does that occasionally.
Then do it.
So
Do his.
Do it.
Do it.
it says I'm connected now.
Why did it say his?
Leave me alone.
But
I was just screaming.
You should say,
Now, I'm just going off of a hunch, obviously. I don't know if it's actually him.
That would be really awkward. Of course.
Hello? Yeah, did you just write on my screen? Oh. Well, I told them I thought it was Grinstead, so they told me to get you back, so, okay.
Watch out.
Yeah, that was me. Okay, all right, I'll try to find out who did it then. You do have that reputation. Yeah, okay, bye.
Are you recording?
Now we gotta
Yeah, I'm
go through
recording.
every single classroom in order
Now I
to
need to
find out
know.
who it was.
All right.
How would you find out? Let's hire a hacker off the left market.
Okay, so what's our equation then? Back to this problem. What's our equation? Xander?
Y equals 3/2 x plus 1/2.
Yes. Yeah. 4.5. If you want to use decimals, that's fine. Next one. Does do they give us the y-intercept value? No, they don't give us any values of x being 0. So what we can do is we can find the slope. What's the rise? Okay, increase of 1. What's the run? Increase 2. So both those are positive. So positive 1/2 just reduces to 1/2, or just is 1/2. Okay, make sure it's not 2/1. Don't put the run on top, put the rise on top. So the slope is 1/2. And then to find the b value, again, if you just kind of missed that because there's a lot going on in the past 3 minutes. If you missed that, we wrote the slope-intercept equation. We plugged in our slope in for m. And then we chose one of the 4 points they gave us to plug in for x and y, and that told us where the b value would be located on that line. And so what's the easiest point to plug in, do you guys think? Carson? 2, 2. Okay, so I'm going to plug in 2 for the x, plug in 2 for the y, although you would get the same answer if you plugged in 6, 4, 8, 5, any of them would work. They'd all give you the same thing. What's half of 2? 1. Subtract 1/2. 2 minus 1 is 1. So the b value is going to be 1, and our y-intercept slope-intercept equation would be y equals 1/2. Don't forget the x plus 1. So there's a little bit of work required when they don't give you the y-intercept value. Now, you could cheat, which I'm all for doing. You could technically find the y-intercept value by just working backwards from this chart. You can see that the pattern here is that they're increasing the x by 2 each time. So if I go in reverse, wouldn't that decrease by 2? And that would give me 0, which is what I want the x to be. And then the pattern for the y's is they're increasing. So if I reverse that, decrease by 1, that would give me 2. What's 2 minus 1? 1. So the 0.01 is going to be on our line. And then we said our y-intercept was 1. So that makes sense. So sometimes you can do that. And then sometimes you do that for this one and you skip right over. You subtract, see they added 2 here. You subtract 2 and you're that -1. So sometimes that doesn't always work. Now I could technically subtract 1 as long as I also cut this one in half and subtract 1.5. And that would give me 2 minus 1.5 is 0.5 or 1/2. And that's exactly what we said it was. Yeah, so it gets a little bit more complicated when you can't. Because if I take away the 2 on top here, that's going to bump me back to -1. So I had to cut it in half. So I landed on 0 instead of -1.
But I thought you had to take away 3 from the bottom one.
But taking away 3 and taking away 2 is the same as taking away 1.5 and taking away 1, which is what I had to do so I can land on 0. So you don't always land on 0 perfectly. So when in doubt, just use this method. That's what I use. Is this the last one? Holy
There's
smokes.
still a lot. Let's do all those that we can't get to.
All right, maybe. Example G. Got to find the slope. What's the slope of this line? Mathematics. 1 over, not 5. Should be 1 over 6. Is it 6? Okay.
Yeah.
Now,
No.
this one is just as bad as the last ones you're looking at because it doesn't cross the y-axis at a very nice spot. So, for example G, I'm forced to go ahead and write down the equation.
We don't have to solve this problem. I mean,
I'm going to plug in 1/6 in for M. They only give me 2 points that I'm for sure are on the line. What's the easiest of these 2 points they give me? Lizzie? Okay, so I'm going to plug in 1 for X and I'm going to plug in -3 for Y. 1/6 times 1 is just 1/6. And then I'm going to subtract 1/6 over. Now remember the -3 is already negative. So when I subtract 1/6 over, it's going to get more negative. It's going to get -3 and 1/6. And if I look there, that looks like, I mean, it's just a little bit lower than -3. So -3 and 1/6 does make sense here. And then I could write my equation. And it's not going to be a pretty one, but it works. Y equals 1/6 X minus 3 and 1/6. So anytime that I don't know what the y-intercept is, or it crosses at a bad intersection, I can go ahead and just use the slope-intercept equation, plug in your M, you gotta find your M, plug in an X and Y from the same point. Don't be crazy and try to plug in this 1 and that -4. It's gonna be from the same point, and then you can get the Y value, the y-intercept value. I had this one on here because there was a problem like this in the homework. How are you doing on that? Have you haven't started it yet? Maybe we should look at this one. Okay, I'm going to call this side 1, 2, 3, 4. Okay, these are my sides, and we have to write an equation for each side of the parallelogram. Now, the nice thing about a parallelogram is that we know the sides are parallel, which means actually the slopes of each opposite side will be the same. So to find the slope of this side 1, I'm going to count from here, I'm just gonna count down 1, 2, 3, 4, 5, 6, over 1, 2, 3. So because I went down 6, I write that as a -6. And because I went over 3 to the right, that's gonna be just 3. And what's -6 over 3 reduced to? Okay, so -2, so y equals -2x. And then to find out where it crosses the y-axis, I could either do what I was doing in the previous problems, or I could just cheat and say, all right, if the slope's -2, go down 2 over 1. Go down 2 over 1. Where is that going to be at? That's probably a little too far, actually. This is -5 at -6. You are correct. So it would eventually cross the y-axis at -6. Okay. Number 2, side 2 here. This one has a horizontal line. What kind of slope do we have on a horizontal line, Owen? It's 0. So y equals 0x, that just cancels out. And where does it cross the y-axis? At -2. So this one's just gonna be y equals -2. Side number 3 is gonna have the same slope of -2 because it's parallel, and parallel lines are the same slope, their slope the same. Okay, it's gonna have a different y-intercept though. So again, I can cheat here. And I can say, well, if I know the slope's -2, that means I can go up 2 and left 1, and then up 2 and left 1 again. And where's that going to put me on the y-axis? 8, 7, 8. Yeah, this is 7. That would be 8. And so I can write -2x plus 8. And then for 4, it's also got a slope of 0, but where's it cross the y-axis? At 4. I want to make sure I get that one in at least. Okay. Now we can skip the tunnel digging one, and we can, you guys understand though, it is really important that you know what the slope represents. So in this one, the slope's going to represent, if I go down, what is the y-axis measuring it? Xander?
How many feet are remaining?
Feet. Okay, and if I go over, the x-axis is labeled in months. So my slope would be how many feet per month that they're digging?
Yeah.
Does that make sense? Can you tell me how long, or tell me, this is distance remaining. So obviously they're going to be done with it in 7 months. How much farther did they have to go before they started digging? So I guess how long's the tunnel? How much digging did they have to do before they started? Jimmy?
3,500.
That's right. So when they hadn't done any digging, they had to go 3,500 feet. Okay, so you should be able to tell from that how much digging they did, when they're going to finish 7 months later, and also how fast they're digging. If I find the slope here, if I go down 1, it's actually going down 500. And if I go over 1, it's actually going over 1. Go figure. And so I can also tell they're digging 500 feet per month. Okay, so that's what the slope should represent. If you label it, it gives you a rate. Okay, so we'll end that, and we'll go ahead and start on our worksheet for tonight. We'll get, there's only 12 questions, and I think you'll like this worksheet. If you like graphic, you'll love it.
Oh, I like
What if
that
you
thing.
don't like